Okay, so first of all, let's finish the leftover for the unit 1. Last time we talked about the naming, right? We talked about naming for the ionic compound. We're left one more thing, which is the naming for the molecular compound. Okay, yeah. So let's talk about the naming for the molecular compound. Okay, so first of all, I would like to remind you what is the difference between the ionic compound and the molecular compound. Okay, first of all, we talk about the ionic compound. Ionic compound, the reason it's called ionic is because they made by the cation plus anion, which is they have a positive charge and a negative charge atoms, not the ions combined together. So they're binding together because the positive charge and the negative charge, they're attract to each other and they generate the electronic attraction. And this is the electronic attraction is called the ionic bond. And they're making bonds like this. So, but the molecular compounds, they do not have a bond. The molecular compounds, they're made by atoms. So they have atom 1 and combined with maybe atom 2 or combined with atom 3. So several different atoms combined together and then they attract by the covalent bond. So that is different. Ionic, they have ions, but for the molecular compound, they are mating by the atoms. Okay, so the molecular formula, when we shows the molecular formula, the formula shows exactly the same how much numbers of those atoms in the formula in a one molecule. For example, we write the CO2, you know, right? CO. N2O, NO2, NO, or even we have a P2O5 and a P4O10. Okay, well, so for those one maybe is easy, but for those two, maybe there's a problem. Okay, this one is a P2O5 and this one is a P4O10. Well, if you're based on the rule for the ionic compound, we said the ratio should be simplified ratio, right? The ratio have to be simplified, but that's not working for the molecular compound because molecular compound, the number of those ions shows of the number of those atoms. It shows exactly how many of those atoms present in the molecule. The P2O5, they have 2 of the phosphor atoms, and then they have 5 of the oxygens around it. So that's making this kind of the molecule. But the P4O10, they have 4 phosphor, and then we have 10 oxygens around it. Okay, so those are 2 different molecules, although the ratio is the same, but the molecule is different. Okay, so you have to space it out what kind of the molecule it is. And if we base on the ionic compound, we're talking about this gonna be the phosphorus oxide. I mean, this is a phosphor oxide, but this is one also phosphor oxide, right? So you cannot tell which one is which. So in the molecular compound, you have to specify how many number of those each of the atoms it has, how many of the atoms each of the atom has. Okay, this is very, very important. And how can we specify what's the number of the atoms? Then you need to add a prefix. And the prefix here we talk about is something like that. If we have one atom, then that's called a mono. If you have two atoms, that's a di. Three atoms, that's a tri. 4 atoms, that's a tetra. 5 atoms, that's a penta. 6, that's a hexa. 7 is a hepta. 8 is octa. 9 is nona. 10 is a deca. Okay, so those are the prefix we're talking about. Okay, are you familiar with this kind of the prefix? Right? Yeah, at least the di, tri, tetra, you probably know. And penta, that's familiar, pentagon, right? The pentagon, that means that has a 5H of the shape. Okay, hexagon, that's 6H. Okay, yeah. Octa usually is called 8. I mean, October is the month of 10, but I mean, previously, originally, the October actually talk about the month of 8. You're just adding January and February in front. Okay, yeah. So, okay, so we're using those as the prefix for specify how many numbers of those atoms we have. Okay, and then let's just talk about how can we apply this. Okay, there's 2 rules. So here we only talk about the naming, only have for the molecule with 2 atoms, 2 different kind of atoms. Okay, so we're only talking about the atoms. So for example, we have like a first atom plus the second atoms. So we're going to have the first kind of atom and the second kind of atoms, only just combined with 2 different kind of atoms. And then for the first atom, then what are we gonna do? You need to add prefix plus the name plus name of element, prefix plus name of elements. Okay, so if there are more than 1 atoms. Okay, in other words, if we have more than 1 atoms for the first atom, then we need to specify the prefix. But if we only have 1 atom for the first atom, then you don't have to specify. Okay, yeah. Second rule is for the second atom. Second atom is always add a prefix. Then you're gonna plus the name of element. And then the ending always is plus IDE. Okay, you're probably already familiar with something ide. Okay, oxide, nitride. Okay, yeah, chloride, fluoride, something like that. So let's just specify this. Okay, so if we have a CO2, CO, N2O, NO, NO2, P25, and P4O6, O10. Okay, so how do we write this? The first one, okay, let's see. first atom, if we need to add the prefix plus the name of elements if there are more than one atom. The first one, the carbon here, they only have one atom, so we don't have to specify. I mean, if there are more than one atom, then we need to specify. For the first one, then that's called a carbon. It's just the first atom is just name of the atom. And the second one, that's always add the prefix plus the name of the elements and plus IDE. So there's oxygen. And then here we have a 2 of the oxygen. So you need to specify the number, then add a prefix, which is dioxide. Okay, carbon dioxide. Okay, carbon dioxide. Carbon dioxide. Okay, the second one, the carbon and oxygen. Again, the first atom only have one carbon, so you just write a carbon. And the second one, you always write the prefix. And since this guy still have one carbon, one oxygen, but you need to specify the prefix. So this is called a carbon mono, since they only have one, monoxide. Carbon monoxide. Okay, carbon monoxide. Okay, so the third one, first atom has 2 oxygen. Well, they more than one, so you have to specify the number. So you can add a di over there. So dinitrogen. And the second one only have one oxygen. So you specify the number and you put mono oxide, dinitrogen monoxide. All right, so please work on those 4. Okay, please go ahead and work on the rest of the 4 to figure out what is the name. Okay, so the first one, that's gonna call nitrogen. You don't have to write the mono nitrogen monoxide. No, you don't have to. Okay, we talk about first atom. If there's a more less than one or just one, then you don't have to write mono. Okay, instead you just write the name. So nitrogen monoxide. The second one is nitrogen dioxide. And then the P2O5 is called a diphosphorus pentaoxide. And that one is tetrahydrogen phosphorus decaoxide. Okay, yeah. So what you need to do is just add the prefix in there. Okay, yeah, that's not that hard. But sometimes, okay, literally I saw this before. Okay, some of the students they write like this, if I write dichlorine heptafluoride. Okay, the students write, okay, this is chlorine, so chlorine, fluoride, okay, that's F, and then put, okay, so hepta, okay, hepta, so they write like a formula like this, okay. Well, just like, obviously, this is not right? We're never, in a formula, we never write a number in front of the elements, right? If we talk about how many number of those elements in the whole molecule, we put those number underneath that. So you should write this as a Cl2F7, right? Yeah. So we're not going to write the number in front of those formulas, okay? But when you're look at our today we talk about this one, right? We talk about this one. This one we have a number 5 in front of this, but this is in front of the whole formulas, okay? In front of the whole water. That means this compound, this formula containing 5 of the water molecules, okay? But if we talk about one molecule containing how many of the elements, we never write the number in front of that, okay? We never write a number in front of that, okay? So just let you be aware, okay? Let you be aware. Don't make the mistake like this, okay? Don't make the mistake like this. All right, so generally this is, then I'm going to give you a little bit summary for the naming of those names, okay? Naming for the formula is, the first thing is not doing the naming. The first thing actually is to characterize what kind of compound it is, okay? We talk about 3 different ways to name. Name of the acid, naming for the ionic compound, and naming for the molecular compound. The first thing is you need to identify what kind of compound it is. Okay, yeah. So now we have those compound shows over there. The first thing is you need to identify what kind of compound for each of this before you name it. Okay, yeah. If you're using the way to name the ionic compound, and then you name that for the molecular compound, that's wrong, right? Yeah, and vice versa. Okay, yeah. So to be honest, I do see some of the students, when we combine everything together, they name the ionic compound. For example, the first one is ionic compound. Why? That's because we have a metal plus non-metal, so that's ionic compound. They call this disodium monoxide. Well, ionic compound, we're not going to specify the ions, right? The purpose for the ionic compound, we're just to make sure each of this has the same charge, the correct charge, then we can write the correct formula. So we're just care about the charge for the ionic compound. But the molecular compound, since they're not making by ions, so we have to make sure how many numbers of the atoms in the molecule. So we need to specify the numbers of the atoms. Okay, yeah, so that's a difference. The first one is ionic compound, so you just call sodium oxide, right? Second one is acid, because we have hydrogen in front. So this is called hydrochloric acid. The third one, again, calcium is a metal. Metal plus oxygen is a non-metal. So this is, again, still ionic compound. So this is called a calcium oxide, not a calcium monoxide. Okay, yeah. This one, chlorine, oxygen, both are non-metal. So that's why we call this is a molecular compound. So we have to write dichlorine and hepta oxide. Okay, yeah. And the last one, again, sodium metal, nitrogen non-metal. So we're gonna call this just a sodium nitride. Okay, so that's why naming, the first thing is not to name. The first thing is to identify what kind of compound it is. Then you're doing the naming. That is a very, very important. That very, very important. Are you with me? Okay. All right, so let's take a break and then we will talk more thing. Okay. Okay, so now what I gave you here is the study guide for the unit 2. Okay, yeah, we're gonna have the new study guide shows over here. Okay, yeah, again, the key to be success is work on the study guide. Okay, that's really, I know we have quite a lot of practice up there. I don't expect you're spent like 10 hours to solving the questions. That's ridiculous. Okay, yeah, spend a little bit of time on each day on this. That's gonna be working. Okay, that's gonna be working. All right, so the next part, we're going to talk about the content for the unit 2. Okay, Unit 2. So generally, Unit 2, the first concept, actually, we already talked about this in the lab. It's just the formula mass. Formula mass. I'm going to just roughly go through this since you already learned this in the lab time, but I'm still going to roughly go through the formula mass. The formula mass generally is just the mass of the formula. If you look at the formula like this one, let's talk about this special one. Okay, this is a barium sulfate. Okay, barium sulfate. Barium sulfate, if you look at it here, we have a one is combined by one of the barium, and then you combine it with two of the nitrate ions of there, So if you think, I strongly recommend you're going to assume the nitrate as a whole thing. So now we have a two of the nitrate. Just think we have two of the nitrate. So once you're making the mass of the nitrate, you don't have to think about, okay, how many nitrogen over there, how many oxygen over there. You combine the mass of the nitrate all together, and then you multiply by 2. That's a good point. Okay, that's a good way to think about this. So now you're going to have a 1 nitrogen in nitrate, and then you have a 3 of the oxygen in the nitrate. Then once you got the overall mass for the nitrate ion, you time 2. That's much more easier to think about how many single nitrogen over here, how many oxygen in total. Okay, you don't have to do this. You just add up the mass inside and then you time 2. That's it. Okay, yeah, so this is much easier for you. Okay, yeah, and then if you look at the mass, well, some of the tips I'm going to show you some of the tips, because I'm not always using the number shows on the periodic table. Sometimes I'm going to do the rounding, but this rounding has a little bit rule, at least as for me. Okay, yeah, for some of the common elements, we usually just round up. For example, hydrogen, if you look at hydrogen, the mass is 1.00795 something. Okay, I usually just round this as 1 AMU. Okay, yeah, because this is really, really close to 1, right? So you don't have to write the rest of this. And for the oxygen, this is also very common elements in the formula. That's a 15.994 AMU. Well, I'm okay just to assume it's 16 AMU. Okay, yeah, because it's really, really close. And if you're talking about nitrogen, well, that's just 14 AMU. If you're talking about for the sulfur, that's just 32. Okay, carbon, also a common one. It's just 12. Okay, sodium, also a common one. I just write 23. Potassium, very common, 39. Okay, yeah, so that is generally what I round up for those common elements. But if you think, if you say, okay, what if some of the elements which is not that common, then what I do? What should I do? Like a barium. Okay, barium, the mass for the barium atom is 137.327 AMU. So should I round to 137, or should I round to 137.3? Okay, well, you see, in these numbers, none of these are 0. So usually I'm not going to round this. I usually round the number when they have a 0 at the part when they have a 0. Okay, but this guy none of this has a 0 in this number, so I usually don't round this number. Okay, yeah, if you're talking about the iron is a 55.4845 AMU. Well, none of this number has a 0. So usually I don't run this number. Usually I don't run this number. Are you clear? Okay. So if you look at the sulfur, okay, sulfur, the reason I run the sulfur like a sulfur is a 32.066. Well, then I usually, you see, this is 0. So I usually just run this to 32. That's it. Okay. Yeah. So this is generally is my rule, okay, to round up the numbers, okay, to round up numbers. But this is for your calculation. Usually in the exam, I will always show the mass for the formulas, giving you the mass of the formula. So you don't have to find the different one and make the different calculations, okay? Now I will give you the mass for the formula, so you will know. Okay, and then you can use that mass to do the calculation. Okay, yeah. All right, so that's it. This is talk about the formula mass. You just need to add them together, then you will got the correct samples. Okay, you will got the correct mass. This is a formula mass. Since we already talked about this in the lecture, in the lab, so I'm going to just talk about barely talk about this. And how to some tips, how to make the calculation more easily and how to run those number and make your calculation easily. Okay, yeah. Any questions so far? No question? Okay. So this is talk about the formula mass. The next one, we're going to talk about the concept, the mole concept. The mole concept. Well, first, let's just talk about, just to let you know, since we talk about the formula mass, we talk about the mass is, if you add them together, it's still really, really small. The unit is something AMU. Well, AMU is a really, really small unit. It's 2 atoms is okay, right? 1 atom, or it's just a several AMU. That's makes sense. But it doesn't make sense to us. Okay, one way in the daily life, in the lab, we are measure things in gram, okay, not in AMU. Okay, so the AMU, the unit is too small to us. We cannot every time we just convert the AMU to the mass, doesn't work. Okay, it's really, really small. So that is why people make a concept for mole. Okay, you probably already heard what is a mole. What is a mole? It's not an animal. What is a mole? Mole actually is a number. You're gonna remember, mole actually is a very huge number. It's a very big number. It is a very big number. And this number is very big and you cannot even imagine that. You cannot even imagine that. What is the meaning of this? Okay, yeah. It's bigger than trillion of trillion. And then you say, what is a trillion of trillion? Okay, yeah. So the 1 mole actually is equal to 6.02 times 10 to the 23rd. And that is a number. Just like when you're thinking about, okay, the reason we call this a number, the mole actually is similar, just like if you're talking about 1 pair, and you know what is a pair mean, right? Pair means 2, okay? So 1 pair, that means it's just times 2, okay? And if you're talking about 1 dozen, and you know, okay, 1 dozen, that means you're gonna time 12. 1 dozen means 12, 2 dozen means 24, okay? So 1 mole is equal to 6.02 times 10 to the 23rd, okay? And 2 mole is just double those numbers. Okay, you probably have no idea, okay? You probably have no idea what is the meaning of the 6.02 times 10 to the 23rd, okay? That makes sense, okay? So let's just imagine that I make some calculations. Anyone has a lollipop? Candy? Okay, so small lollipop is about like this size. I just roughly count this like a 5 grams of the lollipop. It's not very big, okay? Even you have several dozens, it's still not big, okay? Then let's think about it. If we have a 1 mole of the lollipop, do you think how heavy it could be? I mean, you don't have to give me a number. I mean, it's hard to have a number, but you can think about it, okay? Is the mass of a whale, is the mass of a tank, is the mass of the cruiser, is the mass of a mountain, is the mass of a planet, is the mass of a moon or something. Okay, think about it. Just give me some option. So what do you think the 1 mole of a lollipop could be the mass of what? No, I mean, if you have no idea, but let you have some idea, okay? Yeah, so the imagination is give you some idea. What do you think? Okay, so I roughly do the calculation. The 1 mole of lollipop, if we assume the lollipop is about like 5 grams, so 1 mole of lollipop is about 1/10 of the Earth mass. 1/10 of the Earth's mass. Okay, a little bit smaller than the mass of the moon. Okay, so you can imagine. Can you imagine that? Okay, 1 mole of the 1 mole. What does that mean? The 1 mole, 6.02 times 10 to the 23rd. That's really big. Okay, another imagination. Okay, we have a donut. How thick is donut? About like this thick, right? Yeah. So if we have a 1 mole of the donut, you're stacked together. Obviously, it won't stack that much together. But let's just assume if you have a 1 mole of the donut, you stack together, how long the distance it could be? In my previous class, they think about a lot, right? Yeah, we talk about like 10 light years. Well, obviously not that long, okay? Okay, so give me some choices. Huh? To Mars, longer. Saturn, longer. Anyone think about go to the sun? Okay, so Earth to the sun and from the sun come back. Okay, it's about this size. If you're talking about to the Neptune, maybe it's a little bit shorter than that. Okay, yeah. So that's 1 more for the distance, but it's already long enough. Okay, very long. Okay, so this is the number of the mole. Well, obviously this mole, if everything in front of the mole at 1 mole of these things, obviously it doesn't make sense to us. It's too big. Okay. But it's big to the atoms, to the ions, to the molecules, because those stuff already small enough. Those guys are small enough, okay? Yeah, so if you're at 1 mole of the copper atoms, well, that's great, okay? Then we can measure that in gram, okay? If you measure 1 mole of the sugar, well, that's great. That's about like 100 something gram of the sugar. That's 1 mole of that. Okay. Yeah. So that is really good. So we can convert the AMU, those atoms, to the mole, to the gram per mole of something. Okay, well, and the good thing is, if you're adding all of those elements, and you put 1 mole in front of that, then the number of the mass is still the number shows underneath of that. Okay, yeah. So for example, the iron is a 55.845 AMU, but if you talk about 1 mole of the iron, then that's gonna be just a 55.54854 gram. Okay, wow, that's amazing. You even don't have to change any of the numbers. Just use the number, and then you know 1 mole of the stuff is how much in gram. That's cool. Okay, well, I'm not going to talk about detail the history, how we convert the how we got the number of mole. If you're interested, you can search on the YouTube, and also, or you can talk to me after the lectures. Okay, after the lecture. But just to let you know, the number underneath of your periodic table for each of the elements, they can both cause as a unit is AMU, and this is referred to one single atom. But it also is talking about if we have 1 mole of this atom as this same number in gram. That is cool, right? That is cool. All right. Well, then we can got another unit, and the unit the people called is a molar mass. Since we know 1 mole of iron is equal to 55.845 gram. And people also give us another name. It's called a molar mass. Molar mass, which means molar, that means 1 mole. That means if we have 1 mole, how many mass it is? Like the molar mass of iron is just, so the people write molar mass of iron is just equal to 55.845 gram, and not done yet. The unit is gram per mole. Okay, the slash in English, we call this is per, but in calculation, in math, we call this is division sign. Okay, yeah, so generally the molar mass is a gram per 1 mole. Okay, how many gram per 1 mole? So that is a combined unit, gram divided by mole. That is the definition of the molar mass. So the molar mass, the definition actually is if you know the mass of the certain object and it divided by how many mole of this object, then you will figure out the molar mass. The molar mass is just mass over mole. Okay, mass over mole. So that's why the unit mass is in gram, mole is in mole over here. So that's why the unit is gram per mole. And this is what we call the molar mass of the iron. Okay, so the molar mass of the iron, you can molar mass of any of the elements you can find in the periodic table. Does it make sense, right? Well, and combine everything that we learned previously about the formula mass and is doing the same thing. You can also figure out the molar mass of the any kind of the compound, right? Just by adding them together. So instead of you're adding AMU as a unit, you just add the gram per mole as a unit. That makes sense, right? Yeah. So one of the example is just if you put the sugar. So let's see how much mass. What's the mass of the sugar? The sugar is a C6H12O6. So that is a sugar. Okay, the formula. So you can see that's combining 6 of the carbon and 12 of the hydrogen and also 6 of the oxygen. Okay, so if we make the shortcut, okay, we run those number. So carbon actually is 12 gram per mole plus 12 times hydrogen is 1 gram per mole, and plus 6 times oxygen is 16 gram per mole. You add them together, then you will figure out the molar mass for the sugar. 6 times 12 plus 12 times 1 plus 6 times 16, and you got 180. So 180 gram per mole. That means if we have if you measure out 180 gram of the sugar, then you know this is exactly 1 mole of the sugar. Okay, exactly 1 mole of the sugar. So in this case, you see, you generate the relationship between gram and a mole, right? You generated the relationship between gram and a mole. So you see, gram, which is the mass. What is the relationship between mass to the mole? In the middle part, actually, we're using molar mass as the conversion factor between each other's. Gram to mole and mole to gram. Well, just to let you know, usually I will write the unit conversion just like what we did previously. This is time something, and then you can figure out. But just to let you know, mole to the mass or mass to the mole in chemistry is very, 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 very common. It's too common, so I usually don't write like this. I just remember the equations. And I hope everyone is gonna remember this equation. So in the future, if I telling you the gram of something, so the first thought is, okay, this one can convert to mole of this. If you have the gram something, you're gonna already know the mole of the something. Okay, if you have the mole something, then if the question asking for the gram of something, then you know, actually we need to solve the mole of something, and then we convert that to the gram something. Okay, so this is the first thought. So that's why I'm teaching you here as just the equation, how to find the mole and the gram, the mass or mole. Mass actually is equal to the molar mass time mole. The molar mass time mole. Okay, so mass equal to molar mass time mole. And if you're not want to figure out a mole, that should be equal to mass over molar mass. Mass over molar mass. Okay, mass equal to molar mass time mole. Okay, mole equal to mass over molar mass. This is very, very common. Okay, those two equations is very, very common. So I hope you're gonna remember this. I hope you're gonna remember. Once you know the mole, then generally you know the mass. Once you know the mass, generally you know the mole. Okay, so those are interchangeable. Okay, but through the molar mass. Okay, through the molar mass. Okay, very, very, very common. Very, very, very common. So let's do one of the practice, and let's take out the study guides, page number 3. Okay, so let's work on the first one. Questions. First question. Okay, so here is talking about how many gram of 4.50 mole of the sodium fluoride, and they're asking for how many gram of this, asking for how many grams. So first of all, you need to figure out what is the molar mass of the sodium fluoride. So first you need to figure out what is the molar mass of the sodium fluoride. Okay, the molar mass of the sodium fluoride, and just a sodium, one sodium plus one fluoride, right? Sodium, we know is 23, and the fluoride, if you look at the periodic table, is 18.9984. So generally it's 19, okay? So it's 23 plus 19, and we got this is a 42 gram per mole. And that's gonna be the molar mass. Okay, the molar mass. Again, if you want to got a gram, so the mass should be equal to mole time molar mass. Mole time molar mass. Okay, now you got a mole, which is 4.50 mole, and your time the molar mass, which is 42 gram per mole. And if you look at it, see, this guy unit is mole. This guy unit is mole. Again, the mole time cancel the mole, and then the leftover unit is gram. Okay, I'm just giving you the equation instead of using the conversion factor to do the calculation. Okay, so you put that into your calculator. You can see 4.50 times 42. Then you got 189. 189. This is in gram. And are we done? Are we done? You need to, last part is you need to check the sig fig. You need to check the sig fig. The question actually is only giving us one number. Well, again, the molar mass is not count in your calculation. Okay, the molar mass is not count in your sig fig. Okay, so so don't using this count as a sig fig. Only count the sig fig that the question gave to you. Okay, the question gave you 3 sig fig, so you're going to keep 3 sig fig. So here this is only 3 sig fig, so that's great. Okay, 189. That's gonna be the answer. Okay, that makes sense. Okay, yeah. So this is how we solve the problem. Let's do one more question. Okay, the second one. How many moles are in 98.3 gram of aluminum hydroxide? Okay, so we have 98.3 gram of the aluminum hydroxide. Okay, and then they're asking for how many moles of that. Well, again, you're gonna figure out what is the molar mass of the aluminum hydroxide. Okay, aluminum hydroxide, that's making 1 aluminum and plus 1 oxygen plus 1 hydrogen, and your time 3. You see, so this is you don't have to worry about, okay, how many oxygen we have, how many hydrogen we have. You're adding the whole mass inside, then your time 3. This is the purpose. Okay, so you add everything inside, then time 3. So what you got, aluminum, that's a 26.98. So generally it's just 27. And then you plus oxygen 16 and plus hydrogen 1, and you time 3. So that's going to be the molar mass of the aluminum. 27 plus 16 plus 1 parenthesis time 3. You got 78 gram per mole. So 78 gram per mole. That's the molar mass. Okay, so now we're asking for mole. So the mole will be just the mass over the molar mass. Mass over molar mass. That's going to be mole. Okay, mass over molar mass. That's going to be mole. So mass, we have a 98.3 gram divided by the molar mass. 78 gram per mole. Okay, so you see 98.3 divided by 78, and you got a 1.62620256. Well, 1.20 260256. 260256. Well, definitely this is really, really long. And how many numbers we need to keep for this, then that's really depends on what's the number that question give. Question give 3 sig fig, then you just look at 1, 2, 3. So the 1, 2, 3, the next one is a 0. So the answer will be just 1.26 mole. 1.26 mole. That's it. Okay. So it's not that hard. It's just need to carve this information in your mind. Okay. Yeah. But just to let you know, this is just a small piece of the concept. And I hope you can eventually, you're gonna do this as quick as possible. You don't even to look at the notes to say, okay, how to do the calculation. Just remember this in your mind. Okay. So this is because this is a very, very common usage conversion between mole and mass in chemistry. Okay, very, very common. All right. So let's take a break and then we will talk something more. Okay, so let's come back. The last concept I'm going to talk with you is still a relationship. Is the relationship between mole to the molecule number. 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 Okay, so that is the relationship. Okay, well, we already know 1 mole is equal to 6.02 times 10 to the 23rd, right? Amazing number, very big number. Okay, so how can we convert the mole to the number of the molecules? Well, we may not have 1 mole, right? So what if I have 1.5 mole? And then how many number it is? Okay, so now what is the relationship between the mole and molecule number? And generally, the molecule number is just equal to mole times 6.02 times 10 to the 23rd. If you have a 1 mole, that's just a double, and just a time, 1 time this number. If you have a 2, just double this number. If you have 1.5, it's just 1.5 times this number. Then you will got the answer. Okay, yeah, you will got the answer, the molecule number. Okay, but if you want to get from molecule number to the mole, so if you want to get mole, and how can we get from molecule number to the mole? Well, then that's going to be the fraction. So if you have a molecule number and you divide by 6.02 times 10 to the 23rd, then you will figure out moles. Okay, if you have a molecule number, you can use the molecule number divided by the 6.02 times 10 to the 23rd, and you can figure out the mole. Okay, well, so that's just the very simple relationship. So let's turn to the page number 5, or number 4, page number 4, and let's look at the first questions. Okay, page number 4, and let's look at the first questions. Okay, so first the question, it talk about how many molecules. They're asking for molecules. The molecules, and talk about how many molecules. It just talk about how many molecule numbers. Okay, that has a 24 gram. We have a 24 gram of the FeF3 and FeF3. Okay, so how should we solve this kind of problem? Okay. First of all, this is giving you a gram, right? But here we only have the conversion factor between the molecule number and the mole. So actually, this is 3 different conversion. So first, we have a mass, and we know mass can be converted to mole, right? And we also have a molecule number. And the molecule number can also convert mole to mole. So that's why you can convert from mass to the molecule number, and then from the from mass to the mole, and then from mole to the molecule number. So that's 2 jumps. Okay, that's 2 jumps. And in another word, you can also, if you have the molecule number, you can first to figure out the mole, and then using the mole to figure out the mass again. Okay, so that's also a 2 jump. So that's why you can calculate, convert the mass of certain object to the molecule of number, and you can also count from the molecule number to get the mass. The intermediate thing is the mole. Intermediate thing is the mole. Okay, so that's work on these questions. Let's work on this question. Okay, so here is talking about is 24 gram of this to figure out the FeF3. Okay, obviously we need to got what is the molar mass? What is the molar mass of the FeF3? Without this guy, we're not able to solve the problem. Okay, so the molar mass of this is just the iron, which is 55.845, and the plus fluorine, which is 19 times 3. Okay, then we put everything together, 55.845 plus 19 times 3. You got a 112.845. Okay, 112.845, and this unit is gram per mole. Okay, now we got a 24, right? So first we need to got mass to the mole. So mass to the mole, the mole should be equal to mass over molar mass. Mass over molar mass. So you have a 24 for the mass. Again, this 24 gram is a mass. 112.845. This is a molar mass. Okay, make sure which one is which. Okay, 24 is in gram and divided by molar mass. 112.845 gram per mole. And if you're not sure whether the setup is correct or not, look at the unit. Gram is over here, gram is over here, so gram and gram can be canceled. And mole will flip up to become a 1 over mole. Then the mole will be flipped up, so the unit will be mole. Okay, yeah. So let's put this into calculator. 24 divided by 112.845, and you got a 0.2128. Well, so when we solve this problem, then that's going to be a question. Okay, how many numbers do we need to keep for this number? I'm just saying, okay, this is just an intermediate answer because we're not asking for mole. We're asking for molecule number, right? Yeah, so please don't run this like a 0.21. Okay, you need to leave longer enough to make the calculation accurate. Do you understand what I'm talking about? Okay, so I recommend you to, so the sig fig is 2 sig fig, right? So you're gonna keep the number. It's a sig fig, the requested sig fig plus 2. So if it has a 2 sig fig for the question, you keep 4 sig fig. If you have a 3 sig fig for the question, you keep 5 sig fig. Okay, so keep the intermediate question as a 2 more sig fig than the request. Do you understand what I talk about? Okay, so this question, they give us 24 gram, which is we should keep a 2 sig fig in the end. Then you just in the intermediate question, you just keep a 4 sig fig. This is a 0.21268. So I'm going to keep 0.2127. Okay, 2127. So that's going to be equal to 0.2127, and that is in mole. Okay, once you got a mole, okay, so we are going to figure out the molecule number. So the molecule number is just equal to mole times 6.02 times 10 to the 23rd. Okay, 6.02 times 10 to the 23rd. Okay, so you have a 0.2127 times 6.02 times 10 to the 23rd. Okay, so the answer, this is in mole. So answer, calculate 0.2127 times 6.02 times 10 to the 23rd. That's going to be the answer. I got is 1.28 times 10 to the 23rd. Okay, 1.28 times 10 to the 23rd. Okay, and again, the answer is not done. You need to see, okay, 1.28. The answer is the answer shows over here in the yellow sheet is 1.28. But I prefer the answer to write 1.3 times 10 to the 23rd, because the question gave you the only one number, which is 24 gram. And 24 gram is only have a 2 sig fig. So the answer should keep 1.3 instead of 1.28. Are you clear? Okay, so that is the information. And today, I'm going to just assign 6 questions, which is all in the page 3 and page 4. Okay, so please go ahead and work on the question 7, 8, 9 on the page 3. Okay, I'm going to write over here. And also, if you're not sure, I will also post that in the module. Okay, or send an email to everyone. So yellow study guide. As for homework, for the week 4, this is a week 4. Okay, homework for the week 4. So page 3, 7, 8, 9. They all have the answer. Okay, so but the thing is, don't just give me the answer. Okay, yeah, then that's the meaning. That's a meaningless for this homework, right? I need to look at your work. Okay, how you got the answer. Okay, yeah. And then the page 4. 6, 7, 8. That's it. Okay. So page 3, 7, 8, 9. Page 4, 6, 7, 8. That's it. Okay. Yeah. So today it's just doing the practice. This is again, this is a very, very fundamental calculation in chemistry. Okay. Very, very fundamental. Okay. Yeah. All right. So I think we're done here. Unless do you have any questions? No? Okay. All right. Then have a good day and have a good weekend. Again, if you have any concern, any questions, send me email. I'm happy to answer your question. Okay.